Today's lesson is on parallel and perpendicular lines. This lesson is kind of split up into 2 different days because there's a lot of information kind of being thrown at you, and I don't want to overwhelm anyone. So it's split up into 2 different days. Today we're going to talk just about what do parallel lines look like, what do perpendicular lines look like, both graphically and if we're given 2 equations, can we determine whether they're parallel or perpendicular? So the 2 things we're really going to focus on today is slope and y-intercept. So kind of a review, first 3 we're going to find the slope for, and then the second 3 we're going to find the y-intercept for. So remember that y equals mx plus b, m is our slope, and b is our y-intercept. Okay, so if I'm finding my slope, it's just this m value. So m equals 4, y equals mx plus b, m equals -2/5, y equals mx plus b. And this one I don't have any numbers there, but if it's just a variable, I can always safely assume that there's a 1 in front of it, because 1 times any number is just going to be itself. So like 1 times 2 is still 2. 1 times 3 still going to be 3. So my slope is 1. And then for the second 3, we're going to determine the y-intercept. So y equals mx plus b. Here is my y-intercept. B equals -1. Specifically, if we write it as a coordinate, it's 0, -1. The second one, y equals mx plus b. Nothing is here for b, but I can assume it's a +0 because anything +0 is just itself. So as a coordinate, we have 0, 0. And then for the last one, y equals mx plus b. My y-intercept is also, like the first one, 0, -1. Okay, then we had, and just in case you don't remember anything about parallel perpendicular lines never touch. Perpendicular lines will cross to make right angles, and intersecting lines will cross but do not make a right angle. So all lines are going to be one of these 3. They're either never going to touch, they're going to intersect at 90 degrees, forming a right angle, or they're going to intersect at some point, but nothing really special about them. So for this next page, using Desmos, graph each pair of lines and determine if the pair of lines are parallel, perpendicular, or intersecting. So I'll do the first one with you, and we'll determine whether it's parallel, perpendicular, or intersecting. For intersecting on the answer key, I actually wrote neither, but that's okay. Okay, so for this first one, I'm going to open up my Desmos, cancel out everything that I have, type in these 2 lines. So -7x plus 4, not 5, 4. And then my second line is 7x plus 3. I can't see anything, so I'm going to try and hit this home button. And then that kind of reorients. I'm going to zoom in. Definitely doesn't look like they're definitely intersecting, but it doesn't look like they're intersecting at a right angle. So these ones are just intersecting. Okay. Now for the second one, I don't know why it says plus or minus here. This is the symbol for plus or minus. I think it's just a typo, to be honest. You can either have plus or it can be minus. It doesn't really affect the problem at all. Okay, so I'm going to exit out of those 2 equations that I already typed in. So -2x plus 1, and then the other one is 1/2 x plus 4. And again, I can't see anything, so I'll hit the home button, kind of zoom in a little bit, And those appear to be intersecting at right angles. So I'm going to say these ones are perpendicular. And let's see, you're going to do number 3 on your own, 4, 5, and 6. Let's do number 6 together, okay? On your worksheet, I actually have that crossed out. So let's graph these 2 lines here and see what they look like. So I have 6x and then 6x minus 3. We'll hit the home button, zoom in on these 2. Looks like they never intersect. So these 2 are parallel. Okay, so those are the 3 types that you'll have. I want you to do the rest on your own. You can check the answer key to double check your work. And then the last part, you're making a conjecture about what you're noticing. So what do you notice about the equation of the lines that are parallel? And then what do you notice about the equations of the lines that are perpendicular? What do they have in common? What do they have different? Compare what they look like and write those answers here.